Hey Carly.
Hey Wade.
Today we're going to dive into the Python of your favorite algorithm.
Awesome.
So this is k-means clustering in Python. And k-means clustering allows us to take any number of independent variables and predict what clusters are best for this algorithm. So what we're going to do is we're going to look at a new data set that I think you're going to love.
Okay.
So this data set is a data set of specific votes from the 114th Congress. So this data set I have on my faculty website at https://waf.cs.illinois.edu/discovery/congress.csv. This data set contains 15 votes, vote 1 through vote 15, from all 100 senators that took part in the 114th Congress. So we have, in addition to their votes, we have their party affiliation, the state they represent, and their last name. So this data set has a 0 if they voted no, a 1 if they voted yes, and a 0.5 if they were either absent or voted present or abstained from the vote. So we don't know of any of the non-votes. We don't differentiate that in this data set. And what we're going to do is we want to predict, without looking at the party affiliation, whether or not all of the members of the same party are more alike than all of the members of a different party. Because we know there's a lot of party line votes.
Right.
So I think by just looking at how they vote, we might be able to use a clustering algorithm to predict their party affiliation.
Sounds good. I have the data loaded in.
Awesome. So we're going to go ahead and use a machine learning model from the scikit-learn library that we've been using for all of our models. And what's really nice about using the models from the same library is they all follow the same syntax of using fit and predict. So to get the k-means model, we're going to use from sklearn.cluster import k-means. And then I'm going to go ahead and create a new model, which is equal to k-means. And then Carly, if you type k-means and open up the parentheses, Google Colab is going to give you some hints.
Yeah, and it actually says the first parameter is n_clusters, and then I can say equals 2 since that's what we want here.
Yes, we'll say in clusters is equal to 2. And since the first parameter, we don't even have to say in clusters, we could just say 2.
Perfect.
And this is going to create a model that we're going to fit just 2 clusters to all of our data. So there's only 2 political parties here, so we're going to see if we can fit those 2 political parties.
But what about Bernie?
I don't know how he's labeled in this data set.
Independent, I think.
Oh, is he labeled as an I?
Yeah.
Well, it'll be interesting to see if our prediction is right, that we can predict people,
Yeah.
where Bernie Sanders falls, who's the independent in the Senate.
Interesting. I think there might be one more independent as well.
Oh, it'll be something we'll look at in the analysis at the end for sure. That's
Perfect.
a great idea. So let's go ahead and train our model using .fit. So every sklearn machine learning module is always going to have .fit. And here we only have independent variables because we don't have a prediction.
Right. We're just clustering, not making a prediction.
Exactly. We just want to find all the data that's most alike and put all the data into 2 separate clusters. So here, we can think about the list of variables or features we want to use. So I'm going to call this our independent. I'm going to say IND, our independent variables, and I'm going to create a list of all these independent variables. So I'm going to create a open square bracket for a new list. And my first independent variable is vote without any capital letters, so lowercase vote 1. And then I'm going to use all 15 votes. So I'm going to do vote 1, comma, vote 2, comma, vote 3, comma, vote 4, comma, vote 5, comma, vote 6. There's a few easier ways of doing this, but since there's only 15 of them, I'm going to just go ahead and go through all 15 of them by hand because we know we'll get them all in there and we only have to do this once. Vote 12, vote 13, vote 14, and finally vote 15, close my square bracket for my list. So I now have this variable, independent variables, IND, is equal to all of my independent variables, vote 1 through vote 15. So got all 15 of them?
Got it.
Awesome. So now let's go ahead and fit the k-means clustering model. So what that's going to require us to do is do model.fit, and I'm going to open my parentheses, and now I only have independent variables. So I'm going to simply say df at, and then inside the df at, we always give our list of independent variables, but that is actually in a variable, so we can just go ahead and specify IND as the list inside of our data frame.
And I didn't get an error, but I got something that says that k-means is running or
Awesome.
ran.
Yeah, it ran and it returned a k-means object. So it says, okay, I've done some work and now I have the k-means object back. So it has fit our k-means clustering algorithm, and now we can predict the party affiliation of all of the members of the Senate based on these 15 votes using k-means clustering. So what we'll do is we'll go ahead and first I'm just going to do model.predict. And we want to predict the models off the same data. So it's going to be df at ind. So we're going to use the same independent variables. Sometimes we might have two separate data sets, but vote 1 has to be the first thing, vote 2 has to be the second thing. We always have to make sure the order of the data is the same. And if you run this model.predict, I'm going to guess you have a number of zeros and ones.
Yup, an array.
An array of all of the 100 of different affiliations. This doesn't help us because we want to know which politician they predict each entry for. So I'm going to actually add this as a new column to my data frame. So let's call this df at predict is equal to our model.predict. So now we're adding a new column called predict that's going to store the output of this model. Each row now has the entry in that list.
And if I look at my data frame, I see that column added to my data frame. It's called predict, and it is a bunch of ones and zeros.
All right, so now let's go ahead and look at a data frame. Now we're going to do our analysis. So let's go ahead and look at a data frame, and let's see a subset of rows where the party is, we'll do Democrats first. D comes before R. So I'm going to say df at df dot, the party affiliation was in the variable called party. So df dot party, all lowercase, is equal to D. So where is df dot party equal to D? Do we see most of these people have a cluster that is the same?
Let's see. It looks like most of them have ones. I see a couple zeros, but mostly ones.
So it seems that if we think that there's a predictability of a party, we see that most of the Democrats have a cluster of 1.
Yes.
And let's see if the same is true for the Republicans. So let's do df at df.party is double equal to capital R in quotes.
And looking at this, it looks like I see all zeros.
All zeros.
Let me double check. I think, yes, all zeros.
OK, so we can see that there is an identified cluster of zeros here as well.
Yes.
So there is a pretty strong evidence that we've done a pretty good job of clustering them. Let's go ahead and see the mismatches. So what I'm actually interested in is how many senators were classified incorrectly. So an incorrect classification would be a Democrat that is in cluster 0 or a Republican that's in cluster 1. So let's first look at Democrats in cluster 0. So this is going to be a multi-part conditional, so we're going to need two different statements. So this is df at, and then because we have a multi-part conditional, we need parentheses. So df at open parentheses, our first conditional is going to be df.party is equal to D. So we want the Democrats, and then we want to know when df.predict is equal to 0, because we identified cluster 0 is the cluster of Republicans. So how many Democrats were incorrectly classified by our clustering algorithm?
There were 3.
3 Democrats misclassified. And what states were they from?
North Dakota, West Virginia, Manchin, and Nevada.
Nevada. OK, so all kind of swingy states.
Yeah.
So, and let's see if there were any Republicans misclassified. So let's change this conditional to be very similar, where we have df.party is now equal to R, and df.predict is, so we predict they're going to be in cluster 1, which is the Democratic cluster.
None.
So 0 at all. And then I think you said there was some independence in this data set.
Yeah, I know there's at least one.
So let's look at all the subset of rows where the party is I. So let's see, df at df.party is double equal to capital letter I.
And there are two, King and Sanders, and they both
Which cluster
were
did?
in cluster 1. We predicted 1 for both of them.
So we predicted they are in the Democratic cluster, and I believe both those senators caucus with the Democrats.
Yes, you're exactly right.
So it makes sense that their votes kind of look
More
like
Democratic.
Exactly. So this is a really interesting application of clustering, where we took only the data of how they voted, and we found that just by using clustering, giving us no information about their party affiliation, that we were able to get 97 of the 100 senators correct using just a very, very simple clustering algorithm on just 15 votes.
That is amazing.
So this shows the real power of k-means clustering, that you can literally throw just data at this. And as you throw data at this algorithm, it's going to find the data that's most similar and create the correct number of clusters. We did know we needed 2 clusters though. So as a data scientist, there's still a lot of work you need to do to figure out what's the right way to apply this algorithm. And then once you've applied this algorithm, you can then interpret the results because it's only going to give you which cluster ID it is. It just gave you cluster 0 and cluster 1. We had to see that cluster 1 happened to be the Democrats, cluster 0 happened to be the Republicans, and it could have been the other way around.
Exactly.
So this is a really useful tool and just one piece of the machine learning universe that you are going to learn to use and that you know how to use to do amazing work using machine learning.